Hello, in this video, we're going to talk about how we can implement economic order quantity model formulation over an example. All right, so let's get started. In this example, we do have a local distributor and they expect to sell 12,000 cases of chocolate truffles next year. It's a good indication that this will be our demand. I will go ahead and label it like that. And the annual holding cost for the truffles, this is the annual holding cost for truffles, are going to be $16 per case per year. Well, it is right over here. This is going to be our holding cost per case. The ordering cost is $60 per order, and the distributor operates 320 days a year. Given this information, what is EOQ? How many orders will there be next year? What is the time between orders? And what is the total annual cost of the truffles if they are ordered in EOQ amounts? So these are all useful information an inventory manager or supply chain manager or operations manager will need when planning for this kind of operations yearly, monthly, 6 months, and whatever their planning horizons are. In this case, it is 365 days a year, and they are operating only 320 days in a year. So let's get started with the first one, EOQ, economic order quantity model formulation. So we already know that it is actually EOQ or Q star. I will use Q star or EOQ um, interchangeably, and that can be calculated by 2 times D times S divided by H. Remember, we are given those parameters already. 2 times our D is 12,000 times our S is 60, and divided by $16 as our holding cost. And if you do the math, this is actually 300 cases. All right. So we are basically telling the distributor manager, the manager at the distributor, that the economic order quantity, the optimal lot size they should order from their suppliers every time they give an order should be 300 cases for this product. This is powerful information. And remember, if they order this much, they will be minimizing their total holding cost plus ordering cost. We are not worried about the purchasing cost because purchasing costs are not going to change anything. You will be eventually paying for those cases, right? That was one of the assumptions that comes with economic order quantity model. All right, so let's go to the second question. It says that how many orders will there be next year? Well, the number of orders is going to be equal to D divided by Q star. Remember, D is our annual demand. If the annual demand is 12,000, and every time I give an order in terms of lot size as 300 cases, then I should be initiating 40 orders in that year, right? That will be the number of orders that a distributor is going to initiate next year from its supplier. So every time the distributor orders this much, 300 cases, 40 times, they will have to pay $60 as an ordering cost. Okay, that's done. That's done. Number 3 is what is the time between orders? Remember this one, time between orders, we were able to calculate it as EOQ divided by D. We'll have to be just a little bit careful. We already did D divided by EOQ here. This is number of orders. Extra spaces here. Time between orders is EOQ divided by D, and our EOQ is 300. Our demand is 12,000, right? So this should give me 0.02.5 year, right? So the time between orders should be 0.025 year. Remember, in their 1 year, they had 320 days, right? Sorry, I will just, in our 1 year, we do have 365 days. But in their 1 year, they do have 320 days. So given that this is their timeline, what we are doing is, since their time between orders is 0.025 year and their year is 320 days, just to convert this into days, we will multiply these two together. And we see that that's actually, I believe, 8 days. Yep. So their optimal policy is to order 300 cases in every 8 days. So if you have a system that you can automate this, you won't really need to worry too much about the rest, right? So you know that this is going to be the optimal operation. You know that this is going to be the optimal inventory control mechanism for this type of kind of product. And then you just sit back, relax, and monitor the process. We did that, and then now the question is, what is the total annual cost of the truffles if they're ordered in EOQ amounts? We have space here, so remember the holding cost, and we do have in the total cost, we do have the holding cost and the ordering cost. Our holding cost is, remember, our average inventory is just Q divided by 2, Q star, just to indicate that we are running the EOQ operation, times my holding cost, and plus my ordering cost. As you remember, D divided by Q star, this will be the number of orders, and every time I order from my supplier, I will have to pay $60 for it. So if you plug in the numbers, holding cost was, I believe, $16. Yep. And my demand, 12,000 divided by 300 times my 60, which is the ordering cost. You realize that here the holding cost comes out to be 2,400, and my ordering cost is identical to it. And this is not a coincidence. Remember our philosophy, EOQ model, right? So if this is our, and this is our holding cost, this is our holding cost, and this is our ordering cost, and the total cost is going to be right at this point where these two holding and ordering costs intersects. And therefore, since we are running at EOQ level, this holding costs and ordering costs, those are going to be identical to each other, right? Unless you do some rounding whenever you calculate your EOQ, these two cost values might change a little bit, but in this case, our EOQ value turned out to be just equals to 300 cases, so they didn't deviate much. And the total cost would be $4,800.